Alright, welcome back, raccoons. Today we're working on lesson 14's problem set. I've decided to write it down on my paper since I have a little bit more room to write on here. If you need to, you can use your math notebooks, scratch paper, whatever you need to have enough space to do the problem set as well. Let's go ahead and get started with problem 1. We always want to start by reading the problem. George decided to paint a wall with 2 windows. Both windows are 3.5 feet by 4.5 feet rectangles. Find the area the paint needs to cover. When I'm thinking about painting a wall, we definitely want to miss the windows. We don't want to paint on top of the windows. So the first thing we need to figure out is the area of the full wall. So this right here is going to be the area of the full wall. And this number up here will represent that. We don't have that in this problem, but we need to figure out the area of the full wall. Because when we look at the question, what it's asking us to do is find the amount of the area that paint needs to cover. And we know if you look around your house, you probably have windows and they're not painted, but your wall could be painted. So we've got the area of the full wall. When I'm thinking about this, we've got the windows and we've got the painted area. I drew this out to kind of give another visualization to this picture that they drew on their problem set. In this one, this whole thing is the area of the walls. These are the windows. I'm just going to put a W there. And we want to paint everything in that box that is not a window. So when I'm thinking about something that is not a window, and I look at both of my visualizations, thinking about a problem that I could use to solve it, I would say the area of my wall minus the area of my windows, and I'm going to put both windows in bold so I remember that I need to account for both of the windows. So the area of both windows, so the area of my wall minus the area of both windows is going to equal that painted area. And you can look at our tape diagram to show that. The area of the whole wall minus the windows equals that painted area. Same thing in this. Okay, so now we know what problem we're trying to achieve, and we know we're trying to find, if we look at the question, we're trying to find the area that the paint needs. So this is our big mystery for this question. The problem is I don't have either of these values yet. However, I do have the values here, and on your picture, which I forgot to write here, you have the values here as well of the big rectangle. So I'm going to start with the area of my wall because I know I need to start with my area of my wall and subtract the area of both windows. So I'm going to draw my area model, which I know everybody has a preferred strategy to use. This is my preferred strategy I've found. And these have got, you've seen this before with Miss Ferguson's and Mr. Combs videos. But what I'm doing is I'm drawing a big picture and I'm solving for each partial product. So each of these are called partial products. Partial products. And for me, it's a lot easier than doing the standard algorithm, but I'm going to show you that as well. Let's get started. 12 times 8, I know is 96. 7/8 of 8. When I think about 7/8 and 8, I know 8 can be broken down into singles, so ones, and if I'm using 7/8 of those, that's 7. So 7/8 of 8 is 7. when I add up both my partial products, so that's the whole area, adding up both of my partial products, which are 96 plus 7, I get 103 feet squared. Remember, we've talked a lot about this in class too, where if you have an area, you're multiplying for two-dimensional objects, so you're doing squared. If I were to fill a pool or fill a container, I would be using cubed because it's three-dimensional. That's how I like to remember that. Now, if I'm going to do standard algorithm, what I need to do is I need to set up the problem as if I'm just going to solve it. So 12 and 7/8 times 8 equals. And then I need to do, so the first step would be to set up the problem. The second step would be to create improper fractions or fractions greater than 1. So 12 times 8, when we are thinking about fractions greater than 1, just a reminder for anyone who needs that reminder, if something is broken into 1, 2, 3, 4, 5, 6, 7, 8, if a fraction is broken down into eighths, what I need to do to have one single one is to have 8 of the pieces filled out. So if I have 12 single ones, single digits, then I would have 12 times 8, so 12 groups of that 8 plus that 7, which, doing all of that, that ends up equaling 103 over 8. Now, don't get confused by that up there. This is a different strategy, so it's interesting that these numbers end up being the same, but we're not worried about that right now. So then we're still multiplying, we're converting these into improper fractions, or fractions greater than 1. 8 turned into a fraction is 8 over 1. When we multiply across the tops over there, I've already done this, so I know that's 824, but that's a huge amount of multiplication. That's why I prefer this strategy, because that is a really, really big number, and I don't ever have to deal with that big number over here. But 824 over 8. If you remember, we can turn these into much smaller fractions by actually starting to solve them, because fractions are just, division. So 824 divided by 8, 8 can go into 8 one time, 1 times 8 equals, 8. 8 can go into 2 0 times. 8 times 0 is 0. Bring down my 4. 8 can go into 24 3 times. So 3 times 8 equals 24. Minus equals 0. There's nothing left over, so we don't have anything else to do. It's 103 feet squared. So I'm going back up to my visualization up here, and I know the whole area, so the area of the whole wall, the area of my wall is 103 feet squared. 103 feet squared. Whoops, this got blurry at some point. 103 feet squared. Okay. Now I know in my visual diagram that the whole wall is 103 feet squared. Now I just need to find the windows and then subtract those windows from that 103 feet to get my painted area. So let's go ahead and do that. All right, so let's find that area of those windows. So I noticed that my windows in the question are 3.5 feet by 4.5 feet. So I'm gonna draw my area model, and I have 3.5 feet, half is smaller, by 4.5 feet. Now this is obviously not drawn to scale, but we're working with what we got. 4 times 3 equals 12. Half of 4, this one you should already know. If I have 4 cookies and I split them in half, I would have 2 cookies. Those of you in my class know that I often refer to cookies or cats. 1.5 times 3 equals 3.5. If I'm thinking about just multiplying, or I'm sorry, 3 halves. If I think about just multiplying across the top, that's what that would be. You can also think of that as 1 and 1/2. 1/2 of 1/2. So if I had 1/2 and I split that right in half, I would have 1/4. Now I'm going to add up the partial products across each layer. So 12 plus, let's write 1.5, equals 13 and 1/2. Adding at the bottom, I have 2 plus 1/4 equals 2 and 1/4. I need to add these up because I need to add up all my partial products, but they have different denominators. If we're thinking back to how we solve addition problems, we create our t-chart 2, 4 with our denominators, right? So 2, 4, 4. Our least common denominator here is going to be 4. So this one will stay the same. However, we need to change this fraction right here into fourths. 1/2 written into fourths, well, that's 2/4. If I add both of these up, sorry, I'm running out of room here, but if I add both of these fractions up, because remember, right now we're adding all of those partial products, all of these numbers in here, we need to add those together. Those two together equals 15 and 3/4. Well, now we have the area of our window, right? Nope, because we need to have both windows. So we only have one window right now, and we need to have both windows. We also need to have feet squared. If I were to multiply this by 2, I would get 15. I'm sorry, I would get 30. And if I were to have 3/4 doubled, so if I had 2 groups of 3/4, I would have 6/4. Notice that my denominator stayed the same. This is because when I'm multiplying times 2, what I'm really doing is multiplying by 2 over 1. So 2 over 1, multiplying that equals 14 and 6/4. That right there is a fraction greater than 1. So that turns into 31 and 2/4, or 31 and 1/2. So that right there, feet squared, is the area of both windows. If I go back up to my tape diagram, my beautiful, wonderful, lovely tape diagram, I notice I have a spot for both windows. I'm gonna put both there just so I remember. Both windows. Okay, so that's 31.5 feet squared. Now you really didn't have to reduce this. You could have kept this as 31 and 2/4 and you would have been just fine. But I know right off the top of my head that 2/4 equals 1/2, or you could just see 2 and 4, both of those are even numbers. I can divide both of those by 2 to have an equivalent fraction. Now I have my tape diagram ready to go. I have 103 feet is my total. One of the parts is 31 and 1/2. So how do I find 31 and 1/2? How do I find what's left? I subtract 31 and 1/2 from, remember that word from means you're taking it from something else. So I take 31 and 1/2 from my 103 feet squared. And what am I left with? I'm gonna go ahead and just solve this without taking up more room because I don't really have any more room, but that is 71 and 1/2 feet squared. Now writing this out, because remember this is a written problem, so we want to have a written answer. Writing this out, I'm going to put it in the one little box that I have down here. The paint, because remember it says the paint needs to cover, so the paint needs to cover 71.5 square feet. All right, let's go ahead and move on. All All right, let's get started with problem 2. Let's read the problem first. Joe uses square tiles, some of which he cuts in half to make the figure below. If each square tile has a side length of 2.5 inches, what is the total area of the figure? So, first I'm going to underline that question. What is the total area of the figure? Super important to know. That's what we're looking for. We're looking for the total area of this figure. I also noticed that it says square tile. That's pretty important because it only gives us one length. And what I know about squares is that with a square, each side has the same length. Now, obviously, in my drawing, they don't, but pretending that they do. In a square, each side has the same exact length. The length in this one is 2.5 inches. That's also very, very important because we can't solve it without that. So, the first thing we need to do with this problem is figure out how many tiles there are. Or you also need to figure out the area of just one tile. I'm gonna approach it, you can approach it either way, but I'm going to first count the tiles. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 whole tiles. And then let's count the half tiles. 1, 2, 3, 4, 5, 6. I have 6 half tiles. When I'm thinking about halves, so this, and written in another way, is 6 halves, I know that that is equal to 3. So that equals 3 whole tiles. So 10 plus my 3 whole tiles is 13 tiles. So altogether, I have 13 tiles. When I'm thinking about the problem-solving portion of this, I always want to do my problem-solving first. I need to know how many tiles there were. Technically, I could have done this after, so whoops. But anyway, I need to know the total number of tiles, times the area of one tile, because if each one has the area of one single tile, we know that 13 of those tiles will equal the area of the figure. It's really helpful to do this part where you're creating yourself an equation of what the problem is asking you even before you've done this. So I did that a little bit backwards, but it's really helpful to have this information so you know exactly what you're looking for. I'm looking for, in this problem, the area of the whole figure. Now I know one part of that. The first part I have of that is 13. It's not 13 feet squared or 13 inches squared because we're working on inches. It's just 13 because it's 13 tiles. I could write tiles just so I know what I'm talking about. So 13 tiles times that area of one tile. So I need to figure out now, this gives me a step-by-step process of what I need to figure out. So now I know the next thing I need to figure out is the area of one tile. Now I'm gonna figure out the area of that one tile by multiplying the length times the width. Remember, when we're working with area, we're working on length times width. If it was volume, it would be length times width times height. But we're working with 2 dimensions, so we're working with length times width. So I'm gonna build my area model, which is 2.5 times 2.5. Okay, 2 times 2 is 4. Half of 2 is 1. Half of 2 is 1. And half of 1/2, we talked about this in the last problem too, is going to be 1/4. 1/4. Now I'm going to add across the top. 4 plus 1 equals 5. 1 plus 1 plus 1/4 equals 1 and 1/4. These added together are 6 and 1/4. Now we're working with the area of this tile, so we're working with this area model, area of the tile. So that's inches, because it says in the problem set we're working with inches squared. If I were to do this with standard algorithm, because I know some of you prefer that, I would take my 2 1/2, multiply that by 2 1/2, turn both of those into fractions greater than 1, also known as improper fractions, and that would be 5/2 times, 5/2 equals 10/4. Oops, not 10. 5 times 5 is 25. 5 times 5 is 25. I can multiply. Okay, so 25 divided by 4. 4 can't go into 2, but 4 can go into 25. It can go in there 6 times. 6 times 4 is 24. 25 minus 24 equals 1. That 1 is still being divided. Remember, fractions are just division. That 1 is still being divided by 4. So 16 and 1 divided by 4. So it still ends up with 6 1/4 inches squared. It's really whichever method you prefer. I prefer this one. I believe Mr. Combs and Ms. Backlund prefer this one. I'm not sure which one Ms. Ferguson prefers, but whichever one you choose, you're not wrong. So that's the great thing about math. There's more than one way to do it. Now that I have my area of one single tile, I can put it in my problem up here where it has area of one tile. That is 6 1/4 inches squared equals my area of my figure. So now I'm almost there. I just have 2 numbers that I have to work with. I have 13 times 6 1/4. So what I'm going to do is bring this on up, work on my next area model, which is 13 times 6 1/4. 6 times 13 equals 78. 1/4 of 13 is 13/4, because remember, we're just multiplying across the top, and there's an invisible little 1 there if I turn that into a fraction. So adding those together, I have 78 plus 13/4. I should probably turn that into a mixed number, so I'm going to do that by taking 13, dividing that by 4, because fractions are just division. 4 can go into 13 3 times. 3 times 4 equals 12. 13 minus 12 equals 1. That 1 is still being divided by that 4, so it's 1/4. So I have, instead of 78 13/4, I have 78 plus, and I'm just writing it down here because I don't really have room, 78 plus 3 1/4, which is equal to 81 1/4. And since we're working with inches, and since we're working with area, squared. So since this is a written problem, well, I'm going to write this up here. 81 1/4 inches squared. I know that that was the number that I was looking for because I was looking for the total area of the figure, and with my problem solving strategy here, I was able to find that. So I need to write the answer down in a sentence since it's a word problem. The total area of the figure, I'm just rewriting the question, is 81 1/4 inches squared. And you could have written that as 81 1/4 square with the word written out, inches, or like this, either way is fine. All right, thank you. So that's the end of problem 2. We're gonna do one last problem in this video, and then we're going to do the other 2 in a part 2 of this video. All right, let's begin problem 3 by reading the question. All-in-One Carpets is installing carpet in 3 rooms. How many square feet of carpet are needed to carpet all 3 rooms? So we're looking for the square feet of carpet needed to carpet all 3 rooms. So thinking about my first step of trying to figure out what the problem is asking me, I know that it's asking me for the carpet for all 3 rooms. Knowing that, I can say that they want the area of room A plus the area of room B plus the area of room C, and that will equal the carpet needed for all 3 rooms. So I'm going to go ahead and write that down. So area of room A plus area of room B plus area of room C equals the area of carpet for all 3 rooms. That's the problem I chose to go with. Now, to figure out each of these pieces, I know that area equals length times width. So I'm going to make sure, since there's a lot of pieces I'm working with, I'm going to make sure that I note each room. You may notice that I'm starting to write some of this without you seeing it, because I think that you have a pretty good understanding, and I'm trying to get as much done in this one video as we can. Looking at my picture, I can very easily tell the area, the length and the width of room A and the length and the width of room B. The problem is when I get to room C, I have either the length or the width, depending on how you look at it, but I don't have the other measurement. So I need to figure out how to do that. First, before I do that, I'm gonna write the parts of room A and room B. So I went ahead and wrote down the length and the widths of room A and B. I wrote down the one measurement that we do have for room C, but we are missing the other one. If we go ahead and zoom in on our pictures, yours is a little bit neater than mine, but I know that if this length right here, or width, depending on how you're looking at it, measures in 25 and 1/4 feet, because this is a rectangle, I know that this one also measures 25 and 1/4 feet. So what I'm doing is I'm writing 25 and 1/4 feet down here, so I remember this is the length of the whole line, but C isn't that length of the whole line. C is just this part right in between here. However, they did give us this part and this part. So if I'm thinking of it like a tape diagram, the total is 25 and 1/4 feet, but I can take away these 2 parts to have this other part. Let me show you how I did that. So I'm taking the length of room C, and I know that's going to equal 25 and 1/4 feet minus the 2 feet and minus the 2 1/4 feet. Since I'm subtracting both of those, I can add both of these and subtract them both from this total over here, and I'll have what's left over. So my 25 and 1/4 feet minus 4 1/4 feet, well, that just equals 21 feet. So now I have my final measurement, and I'm able to do the computations, the basic math skills, without worrying about the problem solving. The problem solving part is done. I'm ready to move on. I've got my problem solving area right here. I've got this is also kind of my problem solving area. Now I can just work on the computations and figure that out. So I'm going to set up my area models for all 3 rooms and get right back to you. All right, so I used my measurements from each of the lengths and widths of each room, and I built myself some area models. Now I'm not going to do standard algorithm for this problem because the numbers are so large, it would honestly take a lot longer. However, if that's the style you choose to do, you are more than welcome to do that and check in with what I'm doing and see how it aligns, how it matches up. Okay, so 25 times 15 is 375. 1/4 of 15 is 15/4. 25 times 1/2 is, either you can put 25 over 2, but I already know that that's 12.5, so I'm going to write that down. 1/4 of 1/8 is, 1/4 of 1/2 is 1/8. In row B, I'm multiplying 18 times 9 for this partial product, and that gets me 342. Please feel free to pause at any point during this video to get the partial products yourselves and check in back here. 19 times 1/2 equals 19/2. 21 times 16 is 336, and 3/4 of 21 is 63/4, because remember, each of these whole numbers has an invisible denominator of 1 underneath it, because each of those have just one part. Now what I need to do is I need to add all of the partial products within each box below. I add up the partial products, and then I have my area for each room. I'm not done after that, but that's the step I'm going to take right now off camera so that you can have more time in the video. Okay, so I added those up. What I want you to really make sure you notice is with each of these that have a fraction, have just one fraction in there, I have the denominator of that one fraction. However, room A, you did need to go ahead and create yourself a least common denominator chart with 2, 4, and 8 to get your denominator of 8. You needed to convert these fractions into eighths so that you could add them up easier. Now I need to add all of these up, and once again, I'm noticing I have the denominators of 2, 4, and 8. I know my least common denominator with these. I can show you 2, 4, 6, 8, 4, 8, 8. So this one, while you may think at first it would be 4, 8s do not have multiples of 4. So your least common denominator that all three share is 8. So I know my fraction that when I add all three of these up is going to end with a denominator of 8. I'm going to go ahead and plug in my values up here too with my problem solving so I know I'm keeping up with that. So I went ahead and put in my values and I put them with my new denominators of 8. I know that 1/2 down here is 351 and 1/2. 1/2 I can multiply both the numerator and the denominator by 4 to get 4/8. With this last one back here, I can multiply the numerator and denominator by 2 to get 6/8. So now, looking at my problem solving, I know all I have to do is add up the area of room A, the area of room B, and the area of room C to get the area for all three rooms. That added together, you can go ahead and pause the video and do that if you wish. All of those three numbers added together, be very careful when you're adding this many numbers, especially with this big of numbers. It's very easy to make a mistake, but all three of those added together equal 1,094 and 5/8 feet squared. So writing this into a sentence, because we remember that this is a word problem and I need to write it in a sentence, would be all in one carpet needs 1,094 and 5/8 feet squared of carpet. All right, we're gonna go ahead and end this video here, come back and look at part 2 for the rest of this problem set, and then we'll be working on problem set 15 after that. Thank you. All right, let's get started on question 4. Mr. Johnson needs to buy sod for his front lawn. Part A. If the lawn measures 36 2/3 feet by 45 1/6 feet, how many square feet of sod will he need? Part B. If sod is only sold in whole square feet, how much will Mr. Johnson have to pay? So the problem solving part for this would be part A. We know when we're finding area, we're multiplying length times width, so we would multiply 36 2/3 feet by 45 1/6 feet. Before we work out the problem solving part of part B, we know that we have to know what this is because we're wondering how much Mr. Johnson will have to pay, and we're going to be using this, but we're going to work out the problem solving part after we solve for part A. I know that we'll need, just to kind of cover what we'll be thinking about, we'll be breaking that number down into 1,000 because the first 1,000 square feet are 27 cents per square foot. The next 500 is 22 cents per square foot, and then anything after that is 19 cents per square foot. So what we'll end up doing, just to kind of think about how we'll do this, is if the number is over 1,500, we'll solve for the first 1,000, then the next 500, and then anything that's extra. Okay? To kind of keep this moving along, I went ahead and set up our area model. We've got 36 2/3 multiplied by 45 1/6. 36 times 45 is 1,620. 2/3 of 45, well, I know 45 divided by 3 is 15. 15 times 2 is 30. 36 times 1/6, I know 36 can be broken down into groups of 6, and each group of 6 will have 6 in it, so 36, 1/6 of 36 is 6. 1/6 of 2/3. For this one, we'll just multiply across the numerator and multiply across the denominator, and we'll get 2/18. Then we're going to go ahead and add those partial products up right next to it, and we'll have 1,650 plus 6 and 2/18. So for part A, Mr. Johnson, which we'll do the writing after, we'll write for both parts at the end, but Mr. Johnson is going to need 1,656 and 1/9, because we can turn this, we can divide both parts. If you kept it as 2/18, that's perfectly fine, but I went ahead and used my knowledge of equivalent fractions to divide both the numerator and the denominator by 2, and I got 1/9, so he needs 1,656 and 1/9 feet squared, or square feet, however you prefer to call that. Now that we know how many square feet Mr. Johnson needs, let's go ahead and reread part B. If sod is only sold in whole square feet, that seems really important, how much will Mr. Johnson have to pay? So I noticed that they're saying whole square feet, because if you look over here, we're not going to be breaking down this 19 cents into this 1/9. So what we're going to be doing is we're going to be rounding this to a whole number. That way we have enough sod. The thing with rounding is you usually would round this number down. However, we want to make sure he has plenty of sod. We don't want him to run out and then miss that 1/9 square foot. So instead of rounding this number down, because we know he needs to cover absolutely everything, we're going to say that he has 1,657 feet squared that he needs to have. Now, when we're doing the problem solving for this, we already talked about how we're going to use the first 1,000. So 1,000 times 27 cents. Then we're going to use that next 500. 500 times 22 cents. And then we're going to take whatever's left. So what's left from this is 157, yep, 157 square feet. So we're multiplying that times the 19 cents. I'm going to go ahead and do this. So when you're multiplying each of these, you'll get 270, 110, and $29.83. So we add all of those up and we get $409.83. So now we've answered part A and B, but we need to answer it with a word problem. So we can say, or with a sentence. Mr. Johnson needs to buy 1,657 feet squared of sod, and it will cost him $409.83. So we've got our whole problem right there. We've answered part A and B within the same question. All right, we made it to the last problem for lesson 14. Jennifer's class decides to make a quilt. Each of the 24 students will make a quilt square that is 8 inches on each side. When they sew the quilt together, every edge will lose 3/4 of an inch. Part A says draw one way the squares could be arranged to make a rectangular quilt. Then find the perimeter of your arrangement. Part B says find the area of the quilt. So we could do either of these in whatever order. It doesn't matter, but we're going to start with A since it's the first one. And for the problem solving of question 5, it kind of just walks you through it step by step. So we're actually not going to create an equation to solve it. However, we do know that perimeter is every length of the sides, all of the sides lengths added together. And then area, which we're looking for in the second question, is the length of your side, one of your sides length multiplied by the width length. Okay, let's get started. Okay, so since our problem says we're going to lose 3/4 of an inch on each edge, we know that both edges on each side, plus these sides, will each lose that 3/4 of an inch. So when we're looking at this one, this has lost 3/4 of an inch, this has lost 3/4 of an inch, this one has, and this one has. So it still ends up being a square since all of it has lost that 3/4 of an inch. But since we're looking at the top on this side, we're looking at 3/4 of an inch plus that 3/4 of an inch. So it lost on both of these lengths, it lost that 3/4 of an inch. So 3/4 plus 3/4 equals 1 1/2. So our dimensions of each of these squares end up being 6.5 inches. So it's 6.5 inches on this side, this side, this side, and this side. The arrangement I chose was 8 by 3, so 8 squares by 3 squares. Each of these squares, like we just discussed, is 6.5 inches wide, length, any of it, because it's a square. Now, since this first part is asking for perimeter, I know I'm looking for this side, this side, this side, plus this side. So all of these added up. Perimeter is like a fence. You're measuring to see if you want to put a border or something. It doesn't say you're putting a border, but like that's how you would measure that. Area, you're measuring how much room there is on the inside, right? So for our perimeter, we need to find out the length here, we need to find the length here, we need to find the width here, and we need to find the width here. And that's actually going to help us for part B too. So to find each side, we need to multiply what's on top. So 8 times 6.5, we need to figure out how long that is, and that will be the same measurement down here. Let me go ahead and set up my area models for the length and the width. So I've got my area model set up. So this one right here is 8 times 6.5, so I'm measuring for the length here and here. 8 times 6 is 48. Half of 8 is 4. So both of these end up equaling 52 inches. 52 inches. Now for this one, we have 6 times 3, which is 18. And then half of 3 is 3 over 2. 3 over 2 can be broken down into 2 over 2, which equals 1, and 1 over 2, which equals 1/2. So this ends up being 19, because this is 1, and 1/2 inches. So now I know that my length is 52 inches, both of these sides, and my width, both of these sides, are 19.5 inches. For perimeter, what I need to do, I need to add up all of those together. So I need to add up 52 plus 52 plus 19 1/2 plus 19 1/2. And that is going to give me a total of 143 inches. Now, because we're looking at perimeter, we're not looking at the filled in. We're not looking at that filled in. So it's not going to be squared, it's not going to be cubed, it's just 43 inches. I'm sorry, 143 inches. So the perimeter is 143 inches. Okay? Now when we're looking at area, we have two different ways we can solve this. So I'm going to take the length here and the width here, because I already did that, and I'm going to set up an area model for those two numbers. That's my first way. So my first way is to multiply that length times that width, which ends up being 52 times 19, which is 988, and 52 times 1/2 is 26. Now I didn't know these right off the top of my head. I did solve them on the side, so make sure you're doing that as well. Just trying to save up some video space. Now adding those together, I have an area of 1014, and now this time I do have to have inches squared because it is two-dimensional. We're looking at that area. Let me show you one other way we can find that area. Before I show you that way, let's go ahead and write as our word problem, the area is 1014 inches squared. Whoops, inches squared. So the second way I can find this area is I can look at each individual square and find the area of the little square times all of the amount of squares that we have. So that reminds me of problem 2. That's how we did it in that problem. So 6 times 6 is 36. 6 times 1/2 is 3. 6 times 1/2 is 3. 1/2 times 1/2 is 1/4. Adding up all of those partial products, we get 42 and 1/4. Now I'm going to go down to this last little bit of space I have and show you how we take 42 and 1/4. We multiply that by 24, because remember there are 24 students in the class. 42 times 24 is 1008. 1/4 of 24 is 6. So adding up both of those together, and I get the same answer of 1014 inches squared. Remember, in math, there's always more than one way to solve a problem. Thank you for joining me for Lesson 14 problem set, and I'll see you again tomorrow for Lesson 15.